All right, and we are back. Assalamu alaikum, everyone. Bismillah ar-Rahman ar-Rahim. In the name of Allah, beneficent and merciful. I bear witnesses but one God, whose proper name is Allah, who came to us in the divine person of Master W. Fard Muhammad, the great Mahdi, to whom praise forever due. I further bear witness the most honorable Elijah Muhammad, the living, risen, and exalted Christ, and I lastly bear witness to the honorable Minister Farrakhan, reminder, Servant Warner, Messiah, in our midst today. I'd like to greet you all, the mighty, mighty SSOE high school geometry class, with the greeting words of peace and paradise, but in the Arabic language. Assalamu alaikum. All right. So at this time, everyone, we just finished triangle inequalities, and that concludes unit three of our discussion. Unit three of our, not discussion, it concludes unit three of our textbook. So at this time, we've covered Unit 1, Basics of Geometry, Unit 2, Parallel Lines, and Unit 3, Triangles and Congruence. So as you all can probably guess, we will have a test on all of Unit 3 very soon. I'll make sure everybody knows when this test will be. Also, this is a great time to introduce one of our projects, which is highly reliant on the shape triangle. So expect that very soon as well. We will now enter our next unit, which is Unit 4, Quadrilaterals and Polygons, starting off with Chapter 16, which is Parallelograms. All right. And just for context, there are a total of 10 units in our textbook. We are just about halfway through, right? We're almost at the halfway point of our units, meaning we're halfway through the textbook. So keep that in mind. So again, we're finishing up triangles and congruence and moving on to quadrilaterals and polygons. Okay. So without further ado, let's go ahead and share the screen and get started. And here we are, Unit 4. Unit 4, quadrilaterals and polygons. So let's get it. Okay, chapter 16, parallelograms. So if you look at parallelograms, we know that there's a root word present, parallel. So we should recall, because we actually did several problems with pairs of parallel lines and a transversal. Well, what does it mean to be parallel? For lines, rays, or line segments to be parallel, this means that they are aligned in the same direction and they never touch, right? They go infinitely in the same two directions and never touch. So a parallelogram is some type of shape that involves parallel lines, right? Now more, now if we get to go back high level, quadrilateral. So a quadrilateral is a shape with four sides, okay? Very general. If you see a shape and it has four sides, I don't care if they're equal sides, two pairs of equal sides, if they're all different sides, as long as it has four sides and it is a closed shape, meaning that there's no openings, there's no curves, they're all straight four sides. It is a quadrilateral. Okay? It is a quadrilateral. So again, a quadrilateral is a shape with four sides. Quadri or quad meaning four, lateral meaning sides. So there could be other types of laterals or shapes, and depending on what the prefix is, it will tell you how many shapes or how many sides. All right. We name a quadrilateral using the four letters of its vertices. So you see Q, R, S, P, right? So typically, as you all can probably tell, shapes are named in alphabetical order. So this will be named this quadrilateral will be called PQRS. It's not necessarily wrong to name it from any vertice, but generally speaking, it's in alphabetical order, PQRS. So let's move on to now the common quadrilaterals. Now remember, the umbrella term is quadrilaterals, meaning the high level general term. A parallelogram is a type of quadrilateral. Okay. So as you can see on our common quadrilaterals, there's 5 on this page. First is parallelogram. The opposite sides are parallel and equal in length. This is very important. Let's go ahead and zoom in a little bit. So the opposite sides are parallel. So that means that this side and this side are parallel, right? And they're also what? Equal in length. So we can use one parallel uh, arrow for these, right? Now, if we go to these, which are longer, this top and this bottom are also parallel and equal in length. So I'm going to not only use arrows to signify that they're parallel, but also use 2 to signify that they're longer than the other 2 sides. In a parallelogram, all 4 sides are not equal. It's 2 different pairs of equal side lengths, right? And these pairs are the 2 sides and the top and the bottom, right? The top and the bottom are equal to each other and parallel to each other. The right side and the left side are equal to each other and parallel to each other. Rectangle. We all know what a rectangle is, right? A rectangle is where all 4 sides form right angles. All 4 sides form right angles. So a rectangle is also a type of parallelogram, right? It's also, well, you know what? Let me go ahead and write this. A rectangle is a type of parallelogram, but it's a specific type where not only you have 2 pairs of equal sides, right, that are parallel. So similar to the top one, the top and the bottom are parallel and equal, and the 2 sides are parallel and equal, right? But what's key about a rectangle and why it's a specific type of parallelogram is because all 4 angles are right angles. This is not true for every parallelogram. So basically, a rectangle is a parallelogram with all 4 angles at 90 degrees. A rectangle is a parallelogram with all 4 angles at 90 degrees. A rhombus. A rhombus is also a type of parallelogram. It's a parallelogram where all sides are equal in length. Okay. So now, not only are its pairs of sides, right, all the same, right? Right? You still, I want to show differences because, okay, but all the sides are the same, right? All the sides are the same length, but still as 2 pairs of parallel sides. So a rhombus is both a rhombus and a parallelogram. And remember, all of these are quadrilaterals. So every single one of these is quadrilaterals. However, every single one is not a parallelogram. We'll get to that. So far, a parallelogram is a both a quadrilateral and a parallelogram. A rectangle is a quadrilateral, a rectangle, and a parallelogram. A rhombus is a quadrilateral, a rhombus, and a type of parallelogram. Now let's get to a square. A square we know has also two sets of parallel sides, but in addition to being parallel to each other, right? This side and this side, this side and this side are also parallel to each other. So a square has not only a square is also a rhombus, but it's a rhombus where all four corners are at 90 degrees. See that? So see how a square is a quadrilateral, a square, a rhombus, and a parallelogram, right? It's a square because it's a parallelogram where all sides are equal in length and all sides form right angles. It's a quadrilateral because it has four sides. It's a parallelogram because it has two sets of parallel sides. It's a rhombus because it's a parallelogram where all the sides are equal in length. So a square can be classified multiple different ways. The most specific term for it would be square. Okay. So let's go ahead and move on. Lastly, on this page, you have a trapezoid. A trapezoid has exactly two parallel sides. The sides do not have to be equal in length. Okay. Now, with this, it does have two sides that are equal in length. They're just not parallel. The non-parallel sides have to be equivalent for it to be a trapezoid. But the two parallel sides, they're parallel, but they do not have to be, or they're typically not, they do not have to be equal. And they're typically not. They're parallel, but not. There's two different bases, base one and base two, to be a trapezoid. All right. So I pray that that was clear. Let's go ahead and continue. All right. Properties of parallelograms. Properties of parallelograms. Parallelograms have the following properties. Congruent opposite sides. So see, side AD and side BC are congruent, right? They're in green, have the same amount of tick marks. Side CD and AB, they're also congruent, but they're different in this case. But they're congruent to each other and parallel. Congruent opposite angles, right? So angle B is opposite of angle D. They're the same. Angle A is opposite angle C. They're the same. Meaning the angles across from each other are equivalent in every parallelogram. If it's a parallelogram, this is true. The angles opposite are equal. Consecutive angles are supplementary. So consecutive meaning as you go around the parallelogram in almost like a circular motion, right? The angles that are like right next to each other in the sequence. So 4 and 1 are supplementary. 1 and 2 are supplementary. 2 and 3 are supplementary. 3 and 4 are supplementary. Supplementary meaning what? Add to 180 degrees. Right? So again, parallelograms. And this is every one of those shapes we just saw that is a parallelogram shares these characteristics. Congruent opposite sides, right? We know parallel opposite sides, congruent opposite angles, consecutive, meaning that right next to each other in a circular path, are supplementary, add to 180 degrees. 1 and 2 add to 180. 2 and 3 add to 180. 3 and 4 add to 180. 4 and 1 add to 180. Diagonals bisect each other. Diagonals bisect each other. A diagonal connects two non-adjacent vertices, right? They're not next to other, they're across from each other. So AC, BD. Now, again, bisect meaning cuts it in half. So C, right? They cut the BD and AC will cross. And then this segment is going to this one. And then D to here is going to from here to here. So then now this point in the middle, this point of intersection forms what's called a midpoint um, to all the vertices. So this is the midpoint of AC, and this is also the midpoint of DB or BD. Each diagonal divides the parallelogram into two congruent triangles. So this diagonal AC makes this triangle and this triangle. Those triangles are congruent. This diagonal here, DB or BD, makes this triangle and this triangle. They are congruent. Each diagonal by itself makes two congruent triangles. Example, okay? So let's go ahead and zoom in a little more. I know you might have already seen everything, but I still want to go through it. So ABCD parallelogram is a parallelogram. So remember, when going through problems with the given information, it just told you that ABCD is a parallelogram. That means that everything we just discussed regarding properties of parallelograms applies. You see how, like in my mind already, I'm formulating my mind. Okay, the diagonals create two pairs of congruent triangles. The diagonals are bisectors across from one another. The opposite angles are congruent. The consecutive angles are supplementary. Um, the opposite sides are congruent, right? All the properties of parallelograms come to my mind because the example or the problem told me I'm dealing with a parallelogram, right? So now I start saying that. Find the length of BD, all right? So now we're gonna go through this on our own and then go ahead and do it. Okay, so we have A, B, C, D. It's a parallelogram, right? So what can we look at? It's saying that BE and so it says BD is a diagonal, AC is a diagonal, right? We want to find the length of BD. We want to find this length here. Okay? Now, as we can see here, this shape does not look congruent everywhere, but we're going to go ahead and follow their steps, right, to ensure that we're on the right track. So the first thing they do is find the value of x. They want to find the value of x here because if you find the value of x, you can find what this entire length is. Diagonals bisect each other in parallelograms. So AC right here, right, based on what we know, AC divides BD into two congruent segments. Even though, again, I know it doesn't look that way, but that means that this and this are congruent based on what we know, right? Based on what we know. B, I know we can't see D, all right, but B all the way over here make two congruent segments. So that means that BE, right? The segment BE is congruent to the segment ED, right? So again, we're trying to solve for we're trying to solve for the length of BD. So that means from B all the way across to D. We don't know it yet, but we do know that BE and ED are congruent. But we also know now the lengths of those. So now we can set 6x plus 5 equal to 9x minus 19. Now, and I'm going to now manipulate and solve for x so that I don't really have to deal with negative numbers. So I'm going to now subtract 6x from both sides as I start to solve for x. This cancels the 6x, right? And now my resultant next line is 5 equals 3x minus 19. I'm now going to go ahead and add 19 to both sides, right? So now I know 5 plus 19 is what? 24. 24 is going to be equal to 3x because the 19s cancel out. If I divide now both sides by 3, '24 divided by 3 is what? 8. So 8 equals x. The question is now, am I done? No, I'm not. It didn't ask me for x. What did it ask me for, class? It asked me for the length of BD. Very important concept. I can't drive this home enough. In life, you are asked to solve problems. You are asked questions. Your ability to listen, digest, read, understand the questions that are asked in life lends to your ability to answer those questions, right? What makes our teaching so profound is that the Honorable Elijah Muhammad from Master Fard Muhammad and now through the Honorable Mr. Farrakhan answers the questions that not only Black people, but human beings have on their heart, right? Who is God? Who are we? Who is our enemy or the enemy really of humanity? And what time are we in and what must be done? Those are like some of the four major questions that every human has, whether they know it consciously or not. And now, through our teachings, which gives us supreme wisdom and root knowledge, those questions are answered. Now, I know this isn't the gravity of this isn't as big, but still, your ability to answer the question that is asked not only shows comprehension, but a sensitivity to getting to the truth. So we know that x equals 8. So now let's go ahead and plug 8 back into both of these because now it'll give us the actual numbers of the two equivalent algebraic expressions. So we know that 6 times 8 plus 5 is supposed to be equal to 9 times 8 minus 19. So following PEMDAS, we do multiplication before addition or subtraction, right? So very quickly, 6 times 8 equals plus 5, right? So 53 on the left, it should be 53 on the right. 9 times 8 is 72. Minus 19 is 53. So 53 equals 53. So instead of these expressions, these are actually 53 and 53. Again, I know it doesn't look like they're equivalent, but according to our definition of parallelograms, this is the case, and the way this was drawn, which is not to scale. So now if B to E is halfway to B to D, that means BD is 53 plus 53, which is 106, which is equal to BD. And this is our answer. That's fulfilling, right? You got to the actual answer and it should be correct. So again, it started off with understanding that, hey, I have a parallelogram here, right? I have a parallelogram. In having a parallelogram, I know certain things. Some of those things are that the diagonals bisect each other, meaning that the segments on the opposite sides are congruent. So I can set my two algebraic expressions equal, solve for x, plug x back in, get the answer, add the answers together, and get the full length of BD. So let's see. And as we finish this off. All right. So let's go ahead and zoom out. So as we said, diagonals bisect each other in parallelograms. So AC divides BD into two congruent segments. If the line segment BE is congruent to line segment ED, that means the length BE is equal to the length ED. 6x plus 5 equals 9x minus 19. 5 equals 3x minus 19. 24 equals 3x. X equals 8. Find the values of BE and ED. If BE is 6x plus 5, ED is 9x minus 19. Sub in 8, 6 times 8 plus 5, 9 times 8 minus 19, 48 plus 5, 72 minus 19, 53 equals 53. Since BE is equal to ED, we know the calculations are correct. Find the length of BD. BD is BE plus ED. 53 plus 53 equals 106. The same thing we just did. All praises due to Allah. All right. So now, theorems to prove a parallelogram. We can prove a quadrilateral is a parallelogram by using any of the following theorems. If both pairs of opposite sides are congruent, then it is a parallelogram, right? If both sides of both pairs of opposite sides are congruent, it's a parallelogram. AB and DC are the same, AD and BC are the same. If both pairs of opposite side angles are congruent, then it's a parallelogram. A and C are congruent, B and D. It only takes one of these. If one of these is true, then it's a parallelogram. You only need one. If an angle is supplementary to both of its consecutive angles, right? So 4 and 1 to 4 and 3, right? Because 4 has two consecutive angles, 1 and 3. Then it's a parallelogram if they're supplementary. So if 4 and 1 add to 180, 4 and 3 add to 180, it's a parallelogram because you automatically know that 4 and 2 are going to be the same. If a quadrilateral has diagonals that bisect each other, it is a parallelogram, right? A to E to C is the same, and D to E to B all is the same. If a quadrilateral has one pair of sides that is both congruent and parallel, it is a parallelogram. So if just one pair is both the same and parallel, it's a parallelogram. So again, we can prove a quadrilateral is a parallelogram by using any, right? Any of is key, meaning you don't need all of them. If any one of these five is true, then it's a parallelogram. any one of these sides is true, then it is a parallelogram. All right. So we're going to go ahead and wind down and conclude here. All right. And we're going to finish the remaining part for tomorrow. So again, as we conclude, this is unit 4, quadrilaterals and polygons, right? Quadrilaterals is just any four-sided shape. A polygon, poly meaning multiple, gon like side, a multi-sided shape, right? We know that quadrilaterals have 4 sides. Parallelograms are shapes that have the opposite sides are parallel to each other. There's various types of quadrilaterals, right? Parallelogram, rectangle, rhombus, square, and trapezoid. We know that parallelograms have specific properties. They have congruent opposite sides, congruent opposite angles, consecutive angles that are supplementary, diagonals that bisect each other, diagonals that divide the parallelogram into 2 sets of congruent triangles. And we know that we can use one of 5 different theorems to prove that a shape is a parallelogram. Basically, any of those properties, if any one of those properties is true, then we're dealing with a parallelogram. So again, I pray that this was substantive, that we're prepared. Expect again, because we just finished triangles, that now is the perfect time for our one of our projects, and we will be having another exam, inshallah, very soon. May Allah bless us all. I leave these I came before you with the Greek words of peace and paradise. Assalamu alaikum, family.